work done by an expanding gas. Work done by an expanding gas. For example, I have here a syringe, which is like this. And there's the gas in the syringe. And what happens is that there is some force that is being applied on the syringe here. ठीक है, ठीक है, इसके अंदर फोर्स लग रही है, यहाँ पे प्रेशर है, इस तरफ भी प्रेशर पड़ रहा है, इस तरफ भी प्रेशर पड़ रहा है, अंदर भी प्रेशर है, बाहर भी प्रेशर है. ये क्रॉस सेक्शनल एरिया इसका A है, फॉर एग्जांपल. A is the area. ठीक है, you should know that the pressure P of the gas in the cylinder is equal to the atmospheric pressure outside the cylinder. You can see pressure P of the gas in the cylinder is equal to the atmospheric pressure outside the cylinder. And since the pressure is given by, since pressure is P is equal to F over A, the gas produces a force on the piston. The gas produces a force on the piston. You can write here force as pressure multiplied by area. लिख सकते हैं? ठीक है? F is equal to PA. अच्छा जी, what happens is that when the gas expands at constant pressure, the piston will move outwards. ये piston बाहर की तरफ जाएगा. वैसे ही expansion हो रही है गैस की, आप उसको heat up कर रहे हैं. ठीक है, for example. So what happens is that when the gas expands at constant pressure, the piston will move outwards. Yes, I'm going to write here, the piston will move outwards through a distance which we can call delta S. Okay, I can write here, for example, I have here something of this sort. What happens is, for example, this is the area A. The area, okay, and for example, the force is F, and we have the distance delta S. Okay, so what happens is that when the gas expands at constant pressure, the piston will move outwards through a distance delta S. It will move outwards through a distance delta S, right? अच्छा, आप यहाँ पे लिख सकते हैं work done by the gas as force into displacement. Force into displacement. And I can write here F into delta S. यहाँ तक clear? G, online students, Anik, Iraj, Marwa, Bisha, is that clear? F into delta S. We can write here W as फोर्स इनटू डिस्प्लेसमेंट, तो मैंने अभी ऊपर लिखा था F इज इक्वल टू PA. I can write here PA into delta S. Can I write it like this? And this becomes P into A into delta S. P into A into delta S. P प्रेशर है, A एरिया है, डेल्टा S आपके पास डिस्प्लेसमेंट है. ये एरिया इंटू डिस्प्लेसमेंट क्या होता है? एरिया को अगर डिस्प्लेसमेंट से मल्टीप्लाई करें, व्हाट इज दैट? वॉल्यूम. वी कैन राइट हियर P into delta V. Delta V is the volume, na? So delta V is A into delta S. Remember that. ठीक है? So we can write here work done by the gas is equal to P times delta V, where P is the pressure and delta V is the change in volume. और आपने एक बात यहाँ पे ख्याल रखना है कि जो P जो है ये कांस्टेंट प्रेशर है, प्रेशर कांस्टेंट है यहाँ पे. Your work done is equal to P into delta V. This is the work done by the gas when the volume of the gas changes at constant pressure. Remember that when the gas expands, work is done by the gas. Work is done by the gas. And when the gas contracts, work is done on the gas. Work is done on the gas. Okay, let's do a question here. This question came in winter 15 paper 1-1 और summer 20 में भी आया. ठीक है, अगर आपके पास उसने कहा हुआ है वर्क डन इज इक्वल टू P into delta V, राइट? 6 minus 2 into 10 raised to power minus 4 करेंगे आप. इसको जब आप करेंगे तो आपका आंसर आएगा B. ठीक है ना, आपके पास उसने कहा है कि a gas is contained inside a sealed syringe as shown. ठीक है, ये cm क्यूब है तो इसे -6 करेंगे आप ना, -6 cm क्यूब है. So 1 centimeter is equal to 10 raised to power minus 2 meters. 1 cm cube is 10 raised to power minus 6. आपका आंसर B आएगा. फिर एक क्वेश्चन आया हुआ है समर 20 का पेपर 1-3. A cylinder is heated causing the air inside to expand at constant pressure. The expansion of air causes the piston to rise through a vertical distance of 0.5, doing 11 kilojoules of work. Frictional forces are negligible. What is the cross-sectional area of the piston? 11 kilojoules of work है, so work done is equal to P into delta V होता है. You can also write it as P into area into delta H. Now work done is 11,000 joules. The pressure is 2.2 into 10 raised to power 5. Area is what? आपने निकालना है. And height is 0.5. इसको जरा करें, आपका आंसर आ जाएगा. 1 divided by 10 is 0.1. D आंसर बनता है. Concept of energy. ठीक है, you should know that a body which can do work must have energy. A body which can do work must have energy. And you should know that energy and work both are scalar. Energy and work both are scalar. SI unit for energy is what? Is joule. This leads us to the concept of principle of conservation of energy. Principle of conservation of energy. What is the principle of conservation of energy? It says that the total energy in a given system is always conserved. It's always constant. It can never be created nor destroyed in any process, but can be transferred from one object to another from one object to another, or converted from one form to another. However, the total amount remains the same. अच्छा, आपके पास यहाँ पे एक चीज होती है मैकेनिकल एनर्जी. मैकेनिकल एनर्जी में क्या होता है? आपके पास दो किस्म की एनर्जीज होती हैं. एक होती है पोटेंशियल एनर्जी, और एक आपके पास होती है काइनेटिक एनर्जी. पोटेंशियल एनर्जी में दो चीजें होती हैं. एक आपके पास आती है ग्रेविटेशनल पोटेंशियल एनर्जी, और एक आपके पास आती है इलास्टिक पोटेंशियल एनर्जी. ठीक है, आपके पास एक तो काइनेटिक एनर्जी आ गई, एक आ गई पोटेंशियल एनर्जी. पोटेंशियल एनर्जी में एक इलास्टिक पोटेंशियल एनर्जी आ जाती है और एक ग्रेविटेशनल पोटेंशियल एनर्जी आ जाती है. आपके पास यहाँ पे एक मास m है फॉर एग्जांपल, और इस पे फोर्स F लग रही है. अच्छा, इसकी इनिशियल वेलोसिटी थी u. u वाज द इनिशियल वेलोसिटी. मैं अब एक फॉर्मूला डिराइव करने लगा हूं यहाँ पे. अच्छा, इसको इनिशियल वेलोसिटी दी, यहाँ पे s इज द डिस्प्लेसमेंट, this went here, v is the final velocity. ठीक है. What happened is that the object accelerates uniformly, uniform acceleration, uniformly from an initial velocity u to the final velocity v, right? उसकी uniform acceleration है. ठीक है. So the object accelerates uniformly from an initial velocity u to a final velocity v. अच्छा, आपके पास यहाँ पे फॉर्मूला है 2as is equal to v square minus u square. आपके पास एक और, अगर आप इसको लिखें यहाँ पे, acceleration, you know that force is equal to mass into acceleration. तो can I write here a is equal to f over m? I can write here 2 into f over m into s is equal to v square minus u square. and this becomes what? F into S is equal to mv square minus mu square over 2. लिख सकता हूँ? This, what is this F into S? This is the work done. And what is this mv square minus mu square over 2? नहीं, इसको मैं लिख सकता हूँ. I'll write it like this. F into S is equal to mv square over 2 minus mu square over 2. And this becomes what? This becomes, ये derivation बहुत important है, ये आपके syllabus में included है. Yes, half mv square minus half mu square. So you should know that the work done is equal to change in kinetic energy. So the work done, yes, and this is the change in kinetic energy. Delta W is equal to delta EK. Delta W is equal to delta EK. If the object started from rest, then you should know that U is 0. So the work done is equal to half mv square. This equation shows what? This equation shows that the net work done on an object is equal to change in kinetic energy. एक क्वेश्चन करवा देता हूं आपको मैं. ये आया है विंटर 19 में, पेपर 1 क्वेश्चन 17. पहले आप हाफ mv स्क्वायर से इसका मैथ्स निकालेंगे. 1500 is equal to half m is, you have to calculate v is 10. You will find the mass first. फिर उस मैथ्स को यूज करेंगे. तो इस पे रेशियो भी यूज करेंगे. रेशियो भी यूज कर सकते हैं. पहले आप बेहतर तो ये मैथ्स निकाल लें. मैथ्स निकालने के बाद जब आपका मैथ्स आ जाएगा तो हाफ mv स्क्वायर में ये मैथ्स यूज करें और नई स्पीड यूज कर लें. You're done.